Good day, everyone, and welcome to this event at Yale Center Beijing, Yale University's home here in China. And a special welcome to our speakers, Professor Arvind, Narayanan, and Dr. Sayash Kapoor, as well as our commenter, Thomas Luo. Welcome to the center. I'm Carol Rafferty, a Yale College alumna and also executive director of the Yale Center Beijing. And today we are so delighted to be hosting this book talk on AI snake oil, what artificial intelligence can do, what it can't, and how to tell the difference. This is a collaboration with the Princeton University Press Beijing office and is part of the Princeton and Yale Ideas series, where we connect Chinese readers with Princeton University Press's authors on the most cutting edge ideas in our world. So, what's today's talk about? I think the title of the book really perfectly encapsulates what we're going to talk about, which is what AI can do, what it can't, and how to tell the difference. I don't know if our speakers online are able to tell, but at 8 a.m. on a Friday night, you have a full house of people who I see are probably high school or middle school students to working professionals or diplomats or journalists or whatnot. So I hope this would draw a wide audience for your book here in China. We will also have live streaming audience joining online. So we'll be able to tell you the figures, although not as fast as you could with the work you do in artificial intelligence. So we're all very eager to hear what you have to say. A bit of introduction about our speakers and our commenter today. The authors for the book, Professor Arvind Narayanan and Dr. Sayash Kapoor from Princeton University, they have been recognized by Times Magazine as two of the 100 most influential experts in AI. Arvind Narayanan is a professor of computer science at Princeton University and the director of the Center for Information Technology Policy. He studies the societal impact of digital technologies, especially AI, and has co-authored a number of books, actually, including Fairness and Machine Learning, as well as, I found out in the book cover, Bitcoin and cryptocurrency technologies. We need to invite you to speak for us more. These are all very timely topics. Dr. Sayash Kapoor is a PhD candidate at the Center for Information Technology at Princeton University. He previously worked for Facebook, doing content moderation, and conducted AI research at Columbia University and the Swiss Federal Institute of Technology in Lausanne. Our commenter today, Thomas Luo, is the founding partner of GenAI Assembling and founder and CEO of CPlanet and PingWest. Thomas is a prominent alumnus of Tsinghua University and has built a reputation as a keen observer of technological innovation in both China and the Silicon Valley. And before we dive into the discussion, I'd like to especially thank the Princeton University Press Beijing office and our Yale Center Beijing team for hosting this event, as well as this very fun series. The Princeton University Press Beijing office will also be gifting 2 copies of this book to the first 2 people in the audience who ask questions. So this is very exciting, but the book is also available for sale after the event outside. So ka-ching, ka-ching, people will be buying your books. And without further ado, let's welcome our speakers and commenter. Thank you very much.
Thank you so much for that kind introduction. Hi, everyone. My name is Arvind Narayanan. I hope you can hear me okay. I'm going to start us off with a few minutes telling kind of the story of this book, and then Sayash will do a presentation of the contents of this book, and I will chime in from time to time during the presentation. And then I would love to hear your questions, have a discussion, and so forth. Thank you for being here on a Friday evening. Okay, so for me, the story of this book started many years ago when I was doing research on what could go wrong with artificial intelligence. Particularly, I was looking at potential biases that could result. AI, as you might know, uses machine learning technology, and the data that's used for training machine learning comes from data created by people, data about people, and so it's going to reflect cultural stereotypes in various societies. Those could be gender biases, those could be various other kinds of biases. And there, as you might know, there is an active community of researchers who are looking into these kinds of questions. However, around 2019, I started thinking about, are there cases where there are problems deeper than bias? Is AI being used in situations where it doesn't work at all, and we shouldn't expect it to work at all? And in particular, I saw over and over again that there were these hiring automation technologies where these AI vendors would go to companies and say, look, whenever you advertise a job opening, you have hundreds of people, maybe 1,000 people applying to this position. And if some of you are job seekers, you might know, I think this is true all around the world, that there are so many people competing for each individual job. And so the people who are reviewing our job applications, they don't know what to do. There are too many applications to review, too many people to interview. And so the AI companies were saying, look, use our AI product, ask your job candidates to upload a video, a short 30-second video, where they're talking about not even so much their job qualifications, but about their hobbies or whatever. And our product will use AI to figure out their personality and how good they're going to be at a particular job. And it occurred to me that there is no possible way by which this could work. I did not know any evidence that AI is capable of this sort of thing. And coincidentally, at that time in 2019, 5 years ago, almost to the day, actually, I was invited to give a talk at MIT. And I gave a talk called AI Snake Oil, and I pointed to this and other kinds of AI technologies that I thought couldn't work. I called it an elaborate random number generator, and I pointed to evidence from research led by my Princeton colleague, sociologist professor Matthew Salganik. When you look at how well machine learning is able to predict what's going to happen in a person's life, the ability to predict that is only slightly better than random. And that should not be surprising, right? The future is not determined yet. No one can know what's going to happen in the future. Yes, if you have a lot of data and algorithms, you can do slightly better than random, but it's really just picking up crude statistical patterns in the data. It's not some magic technology that can see the future. So I gave that talk. The next day, I put up my slides online. I thought maybe 20 of my colleagues would look at it, but instead, the slides went viral online. And I didn't know that this is something that could happen with academic research. And I was very surprised. Within 2 days, I had 20 or actually more than that, 30 or 40 invitations in my inbox asking me to turn that talk into a book or an article or something like that. And I was very surprised. Why are people so interested in this topic? And I realized it was not because I had said something profound, but in fact, precisely because I had something that many people have noticed independently, that a lot of what is being sold as AI doesn't and probably can't work. Although, of course, there is a lot of genuine progress in AI. We talk about that in the book as well. But while there are many people pushing back against faulty AI, there are relatively few computer scientists saying, look, I understand how AI works. I built AI technology, and I'm telling you that there is no way that this particular application of machine learning can possibly work. Uh, So I felt like that's a story I wanted to tell, but at that time, I didn't feel ready to tell that story. I felt like a lot more research needed to be done. So I was very glad when Sayash Kapoor joined my team. And as you heard in the introduction, he has built machine learning technologies at places like Facebook. So he has seen what they can be useful for, but also what their limitations have been firsthand. And we've been doing research for many years, and we've found many surprising things in the course of that research. For instance, we've been looking at AI for science, and of course, it can be very powerful. We've had a couple of Nobel Prizes for the application of AI to scientific discovery, but we've also seen how it can really go wrong when scientists carelessly apply machine learning. There can be errors in the claims that you make that go undetected, that are sitting in the scientific record until years later someone realizes that this discovery is actually bogus. And we think that's a little bit of a crisis going on right now in the scientific world. And we've written papers exposing the scale at which these mistaken claims are being made. So it's been a learning process for us, and we're so excited now to share some of those learnings with you. So with that, I will turn it over to Sayash. Thank you again for being here.
Absolutely. Yeah. Thank you so much for being here, everyone. And thanks, Arvind, for that wonderful intro. So I wanted to start us off with the three words in the title of the book, just AI and snake oil, and basically talk about what we even mean when we use these words AI. So I think it's very surprising that despite 80 years of work in this area, it's still really hard to give an overarching definition of what constitutes AI. But in the book, we use a three-factor test, three loose criteria to determine if something is or isn't AI. So I found this sort of definition to be useful. I hope it is for you as well. The first factor is whether the task that we're using using AI or using a tool to solve requires some creative effort or training for humans. So one example is text-to-image tools that generate an image based on a prompt in the text. This would be an example of AI by this definition, because creating images or artwork requires creative effort or training for humans. The second criteria is that the behavior of the tool should not directly be specified in the code by the developer. So one example of such a tool might be a rule-based tool, which sort of looks at your conditions and takes a specific decision based on that. In fact, even a thermostat, in some sense, has its code or has its behavior directly specified. So if the temperature goes above a certain degree, you turn on the cooling. If the temperature goes below a certain degree, you turn on the heating. That is not an example of AI. We do want the behavior to be learned from patterns in the data, rather than directly being hard-coded by the developers. The third and final criteria that we outline is that there should be some flexibility in the inputs that we use to give to the tool. So for example, if we are using an AI tool to distinguish between images of cats and dogs, the tool should work about as well, or the tool should be able to take in inputs that it hasn't seen before. So it shouldn't just work on images of dogs and cats that the tool has seen before, but rather it should generalize to some extent to images that have not been seen before, even if there's some accuracy loss. So this is like an overarching definition of what we mean when we use the term AI. Now, of course, as you can tell, this is a really broad definition, and we'll come back to that in a minute. But I wanted to dive a little bit further for just a minute, which is what is the dominant paradigm for using AI today? And that is machine learning. So machine learning refers to learning from examples and learning patterns in the data using these past examples. So for example, given enough photos of cats on the one hand and dogs on the other, a machine learning system can learn to distinguish between the two. I find this a hilarious example of the difficulty of trying to tell apart a Labradoodle, which is a type of dog, from fried chicken in these images. But given enough images of Labradoodles on the one hand and fried chicken on the other, AI systems can, in fact, today learn to distinguish the two. And to create tools like ChatGPT, a very similar process is followed. So instead of these labels being provided by a human, the labels are generated automatically from existing data, say on the internet. So for example, if the sentence, "What is your name?" appears in the training set or appears on some internet data, it might turn into 4 different examples used in the training data for tools like ChatGPT. So the first example is, "What is your blank?" And the correct answer would be name. The second example is, "What is blank name?" And the correct answer is your, and so on. And so machine learning really is what powers a lot of the advances that we see in AI, especially in the last few years. So this brings me to the next part of the title, which is, what is the snake oil in the title AI Snake Oil? So snake oil refers to this long-standing, or rather old tradition, especially within the United States, but all over the world, of salesmen selling snake oil ointments as a cure for every single possible disease. So for example, this poster here shows an example of Clark Stanley snake oil, which was claimed to cure everything from rheumatism to kidney stones to back pains and so on. Now, of course, these medicines or oils did not really work very well. And in the United States, the Food and Drug Administration was established in part because of these false advertising claims. And as Arvind mentioned, we think there's something similar going on with AI today. So this is a screenshot of the example he mentioned in the beginning. This is a tool that claims to predict how well a candidate might do at a job, and is being used by, companies that are seeking to hire people to decide whose application to move on to the next stage and whom to reject. And this is the sort of information this tool gives out. So note that it has like a lot of detailed information about every single person. In this case, on the top right, you'll see that this person is flagged as being assertive, and it even gives out a score. So in this case, the score is 8.98. Notice the 2 decimal points of precision. So it's really talking about how accurately this tool can determine how well this candidate would do. And as Arvind said, we think that many of these types of tools are essentially elaborate random number generators. There is no evidence, very little peer-reviewed work showing that these tools have any efficacy at all, let alone at predicting how well someone will do at their jobs. And I think this is the core of our message. So our key message in the book is that the most confusing thing about AI is that AI is an umbrella term. It is the same term is used to refer to many different types of technologies, which have very little to do with each other under the hood. So some of these technologies have made massive progress in the last 10 years. For example, generative AI. So the image here is an image generated using OpenAI's text-to-image tool called DALL-E. It was an image generated using just a very simple prompt, an astronaut riding a horse. And this is the image it came up with. And clearly, we've been making improvements to text generation models like ChatGPT, to image generation models like DALL-E, and also to generative AI in other domains like protein folding. All of these have indeed been transformative. On the other hand, we have tools which we call predictive AI. These are tools that are used to make predictions about individual people's futures, and on that basis, make decisions about whether or not to hire them for a job, or whether they should be released on bail when they're being criminally charged, or whether what their insurance rates should be, or whether they should receive insurance, and so on. And I think this is where we find a lot of snake oil. And we'll come back to predictive AI in a minute. But in the book, we also cover 2 other types of applications of AI, including social media algorithms, both the algorithms used to optimize for engagement on social media, but also, more importantly, the algorithms that are used to moderate content or to take down content if it does not agree with the policies that a social media platform has. And finally, we briefly talk about robotics, including in self-driving cars in the book as well. Okay, so let's get back to predictive AI, which is where I mentioned there's a lot of snake oil. So what we think is happening with predictive AI is that vendors who are selling predictive AI exploit the public's confusion over the different types of AI. They sell their tools as if they're state of the art, but under the hood, these tools are doing something fairly unsophisticated. For example, I really like this sort of a case study of Retorio. Retorio is a hiring company. On its website, it claims to identify and drive winning behaviors for different types of jobs, including customer service. And they use AI-powered video analysis to make these determinations. Now, in most cases, when companies make these claims, we don't really have the tools to assess how well their tools work. But in this case, an investigative journalism group was able to get access to the tool and test out how well it works. What this found was astonishing. So the same video of a person with just the background in the back changed led to dramatically different scores. So for example, in this image here, if someone was speaking in front of a plain background, they would get a much lower score compared to if they have an image of a bookshelf in the background. And they found many other such cases which highlighted that these tools are essentially relying on correlations in the data. They don't really look at what the job candidate is saying, but rather on superficial appearances, such as whether there's a bookshelf in the camera. Now, this might seem like a funny example, but indeed it can be consequential if you're a job seeker. But predictive AI has actually been used for far more consequential applications. For example, in 2013, the Netherlands deployed an algorithm to detect welfare fraud. That is, if families with children were taking money from the state and in a fraudulent manner. The algorithm wrongly accused thousands of families and sent many into debt. In some cases, families were asked to pay back over 100,000 euros. 6 years after the algorithm was introduced, it was finally found out that the algorithm had these flaws and it was discontinued. And over the fallout over the algorithm's use, the Dutch prime minister and his entire cabinet had to resign. There are also examples within the US. So in 2017, US healthcare technology company Epic launched a sepsis prevention algorithm and claimed to have an extremely high accuracy. 4 years later, when an independent investigation was conducted on the efficacy of this algorithm, it found that the accuracy was actually much lower. So while Epic had claimed a relative accuracy of about 80%, the actual accuracy was about 60% or so, much closer to a coin toss. And 1 year after this investigation, Epic discontinued this one-size-fits-all sepsis prediction model. Now, if companies can indeed predict sepsis early, that would be a huge advance because sepsis is one of the deadliest diseases, especially in hospitals. But here what we're seeing is there is inadequate validation of these tools in the real world. And finally, another example from the US is the US state of Oregon in 2018 implemented an algorithm to predict if children are at risk of maltreatment. But after widespread reports of bias against Black families in particular, the tool was discontinued in 2022. So you'll note that all three tools here are examples of predictive AI. In many cases, these tools just don't work as well as they're promised to, and that eventually leads to fallout over these tools' use. But in the meantime, they're actively causing harm to job seekers, to people who are taking child benefits, and so on. And in fact, there have been hundreds of such incidents in the last few years in fields like insurance, to mortgage, to the DHS, to the Department of Homeland Security, and so on. And I think this is what leads to our pessimism about predictive AI. And in fact, we have an entire chapter in the book about how difficult it is to predict these life outcomes. So it's not just about AI going wrong in these cases, but rather that many of the types of things we are trying to predict with AI might have fundamental limits to their predictability. So maybe I'll stop here for a minute and let Arvind chime in.
Sure. Thank you. Yes, I don't have too much to add. I'll talk for a couple of minutes and then we'll, at the end of the presentation, I'll say a little bit more about what's in the book. Unless you actually want to go to that slide, Sayash, then I can go through that slide if that's okay.
Perfect.
Great. So this is our way of thinking about all of the things that can go right or wrong with AI. So we have placed, and this is from the introductory chapter of the book, we have placed various applications of AI into this two-dimensional chart. On the x-axis, what you see is a spectrum. Some applications of AI are completely fine. For instance, autocomplete in our phones, that's an example of AI, or at least it would have been called AI at one point, but it's no longer necessarily called AI today. I'll come back to that point. We have a slide on that. And on the right-hand side, we have many applications of AI that we think are harmful. So if you look at the top right, for instance, we have criminal risk prediction that Sayash talked about. We don't think AI should be used to predict who might commit a crime in the future. That's just not something we should use AI for. And similarly, video interviews, we don't think AI should be used for analyzing people's videos to see how well they will perform at a particular job. There's just no basis to expect that to work. So that's the x-axis. But on the y-axis, what you see here is that regardless of whether something works well or doesn't work at all, that's the y-axis, it can be either benign or harmful. So for instance, autocomplete works really well, but if you look at the bottom middle, image generation for stock photography, it's true that image generators like DALL-E or Midjourney or even video generators can do a really good job. That doesn't mean that that application of AI is completely okay. There are some problems with that. The big problem with that application of AI is that it is trained on data created by artists, photographers, and other creative people, and they are not being compensated in any way. So this is something we talk about in the book. As a society, how can we remedy this injustice? I think that's an important question we should ask. It's not that we should stop using image generators. That's not what we're recommending. We use image generators ourselves. This is less of an issue for individuals to be aware of and more of an issue for society, for regulators, for the media to bring attention to, and so forth. So on the bottom left here are things that are that both work well and are not really problematic. So another example is code generation. As you might know, you can use AI to automatically generate code. It can even create entire apps, relatively simple apps. Again, these are things we make use of ourselves pretty heavily. It's not a really problematic application of AI. We do have to think about, are there security bugs in the generated code, for instance? There is research showing that AI-generated code can have more security vulnerabilities, making it more vulnerable to hackers. That's something we all need to be aware of. But overall, that's an application of AI that we very much approve of. And going back to the top right, sorry, if you could stay on that slide, Sayash, going back to the top right, we talked about criminal risk prediction. We talked about video interviews. Another one here is cheating detection. So what this is talking about is, as you might know, many educators are concerned that students are using ChatGPT and other AI tools to do their homework. And so there are a lot of AI products claiming to detect which homeworks are AI generated. And perhaps some of you have experience with this yourselves, that these tools don't work well. And all over the world, students are getting falsely accused of cheating using AI. And we think that is a huge, huge problem. Instructors shouldn't be using these. They should be modifying the education system so that they don't have to worry about whether students are using ChatGPT or not. We have been doing a lot of that work ourselves in our own teaching here at Princeton. So that's the bottom left, and that's the top right. On the other hand, there is something like predicting civil wars, which you see in the closer to the top left here. So that is a case where it's not a commercial application of AI, but instead it is a scientific application of AI. A lot of papers in political science that said we can accurately predict where civil wars are going to happen using AI. And our investigation showed, we have a paper on this, that all of those papers had errors. That doesn't work at all. And just like we said, we shouldn't be able to expect to be able to predict people's future behavior, who might commit a crime or who will be good at a job. We also shouldn't expect to be able to predict where wars will happen. There are theoretical reasons to expect that wars are fundamentally unpredictable. So this is a theme that we keep coming back to over and over in the book, that the future is fundamentally unpredictable. So one last thing I will end with, Sayash, if you could go to that slide. There's a funny definition of AI that says AI is whatever hasn't been done yet. So what does that mean? AI is whatever hasn't been done yet. So when an application of AI starts working really well, like we have a bunch of examples of these in the slide. So things like the Roomba or other robot vacuum cleaners, or even web search and so forth. So all of these examples on the slide, we probably use on a daily basis, right? Speech recognition, we all dictate text to our phones. They work really well. And when that happens, it kind of fades into the background. We take it for granted. We stop calling it AI. It's when an application of AI is new, like much of generative AI today, when it can work well, but also can really go wrong, when it has societally double-edged implications, that's when we are more likely to call it AI. And so that's what it means. AI is whatever hasn't been done yet. The definition of AI constantly keeps getting redefined so that it's always at the frontier of what is possible. And that's part of the reason why AI doesn't have a technical definition. It's more of a sociological definition of what we collectively choose to call AI, because we want to indicate that it's cutting edge technology. And so what we predict is that much of what we call AI today, like self-driving cars, those are called AI today. But one day, even though self-driving cars today occasionally get into crashes, there are even deaths due to self-driving cars. One day that'll be a solved engineering problem. We think the number of accidents from self-driving cars will drop to nearly zero. There are historical examples of this. When elevators first were a thing, there was a huge amount of concern about their safety, but now, of course, elevator accidents are extremely, extremely rare. And so we think this will happen with self-driving cars. We won't call it AI anymore. We'll take it for granted. In fact, we will even drop the term self-driving. We will just call them cars, most likely, and we'll need a new term like manual car for what we call cars today. And so that's our optimistic vision for the future of AI. This is the kind of AI we want more of: tools that do a specific task, that work well and don't have these kind of dubious societal implications, like many other technologies like criminal risk scoring. Self-driving cars are going to save, perhaps on the order of 1 million lives per year that are lost today due to car accidents. On the other hand, criminal risk scoring will never become this technology that we take for granted, I think, because the problems with it are not technical. It's not that we need more data to better predict the future. It's rather that the future is fundamentally unpredictable, and it's not morally justified to predict what someone is going to do and punish them on the basis of that. It's only morally justified to punish someone on the basis of what they have already done. And so because of that, criminal risk scoring will not become this acceptable technology that we take for granted, but self-driving cars will. That's our prediction. And so hopefully that gives you an idea of the distinction between the kinds of AI that we want more of and the kinds of AI that we want to push back on. Okay, back to you, Sayash.
Fantastic. Thank you, Arvind. So maybe in the next 10 minutes or so, we'll quickly jump into one other chapter in the book, which talks about how AI hype persists. So I think one reason for AI hype persisting is clear, which is that companies conflate the different types of AI, which have very little to do with each other, things like generative AI and predictive AI. And while generative AI has made a lot of advances over the last decade, predictive AI essentially relies on decades-old technology. But when companies conflate these two, that results in hype about these products. But I think there are also companies that sell generative AI tools, or there's essentially a lot of hype around generative AI tools themselves. Here's what I mean by that. So this is a screenshot of the abstract of OpenAI's technical report when it released the GPT-4 series of models. And in that abstract was a very interesting sentence. So OpenAI said that GPT-4 exhibits human-level performance on various professional and academic benchmarks, including passing a simulated bar exam with a score in the top 10% of test takers. What this sentence was interpreted to mean very widely, including in the press, was that GPT-4 is about to replace lawyers. But if you think that's what's likely to happen, I think that is an example of AI hype as well, which was peddled quite heavily by these news organizations once GPT-4 was launched. And that's because it's not a lawyer's job to answer bar exam questions all day. And so when we rely on these benchmarks to say how well these tools can be used to solve real-world tasks, or perhaps even do the job of a real person, I think that leads to exaggerated claims. Now, these exaggerated claims are not new at all. So this is Geoffrey Hinton, the recent Nobel Prize winner in 2016. In 2016, he said, and I'm quoting him, is if you work as a radiologist, you're like the coyote that's already over the edge of the cliff, but hasn't yet looked down. So he doesn't realize there's no ground underneath him. He goes on to say people should stop training radiologists now. It's just completely obvious that within 5 years, deep learning is going to do better than radiologists. Mind you, the statement was in 2016. In 2024, there was a worldwide shortage of radiologists. So why is this disconnect happening? I think one of the reasons is that methods experts, like Jeff Hinton certainly is, so experts who sort of think about AI very deeply, perhaps don't really understand what it is for domain experts, people who work as radiologists or lawyers or what have you, what it takes to actually do their jobs very well. So they're not in the best position to talk about the impact of AI on those jobs. So that's certainly one factor. Another factor is that the AI we have today perhaps might not be up to the mark itself when it comes to replacing radiologists. So here's what happened, and this is like an example of how an AI tool that was trying to diagnose pneumonia from chest x-rays went wrong. So this is an example of the chest x-ray. And the tool was meant to sort of diagnose pneumonia on this basis. But what instead happened was, as you can see on the slide, on the top right, almost the entire sort of reason the AI model was making its decisions about pneumonia was based on whether or not there was a hospital token on the top right side of the image. So instead of looking at the lungs for evidence of pneumonia, all the AI tool was doing was recognizing what token the hospital had put on the top right side, and on this basis, making its decisions. So this is an example of a failure in AI tools that we'll come back to. But for the moment, let's come back to this sort of map of how AI hype persists. So the first reason for AI hype is that companies make tall claims, whether it's predictive AI companies sort of claiming to sell AI and conflating between different types of AI, or generative AI companies that overclaim how well their tools work and how general they are. Now, let's head back to the sphere of research for a minute. So how do we tell in AI research how well a system performs? The best way of doing this, and the most widespread way of doing this today, is by using something called benchmark datasets. So for OpenAI's example, the dataset that they used was that of a simulated bar exam, where they took a number of questions, mostly multiple choice questions, and asked the model to respond with answers. And what you then do is you train the AI systems on one part of it. But crucially, you set aside, let's say, around 30% or half of the data set to evaluate the AI models on that test set. And this part is essential to machine learning more broadly, because if you don't separate out this data set, if you evaluate your AI on the same data set it was trained on, then you're essentially teaching to the test. So the AI tool can essentially memorize the examples in the data set that it was trained on. And this is an example of what we call leakage. So there is information that is leaked about the data set to the AI tool by virtue of being trained on the entire data set. And there's no sort of hidden test set that it can be evaluated on. So this is one example of leakage. There are other examples as well. So the chest X-ray image that we saw a few slides earlier is an example of what happens when we rely on these AI tools that only have like the answers already sort of hidden in the chest X-ray. So if there's like a token that indicates that a chest X-ray scan is from a particular hospital, that makes it more likely for the AI tool to work well on images from that hospital, but not from other ones. So as Arvind mentioned, a few years ago, we started looking at this problem in the field of civil war prediction. And we found that every single paper which claimed that AI tools did better than decades-old regression methods, every single one of those papers suffered from some or the other form of leakage. And in fact, this sort of led us to investigate whether leakage is also an issue in other science fields that are adopting AI and machine learning. And when we looked at ML-based science, that is scientific research that uses machine learning, we found that leakage is widespread in these fields. So this is a screenshot from a paper from 2023, where we found that over 294 papers across 17 different scientific fields suffered from leakage. And perhaps more surprisingly, we found that each of these fields was independently rediscovering what it means for AI results to be impacted by leakage. We have since updated this survey. So in our latest run, we found over 600 papers across 30 different fields suffering from leakage. And we think it very much is contributing to a crisis in science. In fact, this crisis has been outlined by several sort of journalistic pieces, and others have also got onto it. We've heard about data leakage causing issues in healthcare, in machine learning, research in other scientific disciplines, and so on. And while there are genuine advances, absolutely, that AI has led to, things like AlphaFold and protein folding models that have rightly been recognized, there is also a vast amount of research that suffers from this reproducibility crisis, primarily because of leakage. Okay, so let's come back to our map of how AI hype persists. So our first part was companies making tall claims without transparency. In addition to that, AI research is suffering from a reproducibility crisis. And what these two things together mean is that most of the prominent AI results that we see are likely to be exaggerated. On top of that, we've also seen a lot of input by public figures. So for example, when GPT-4 came out, many influential people signed this open letter that called for a pause on giant AI experiments. This letter also mentioned that AI that is more powerful than GPT-4 could pose civilization-level risks, perhaps even the risk of extinction. And on that basis, all of these signatories were asking to pause these experiments. We call this an example of criti-hype, that is criticism at face value, which also leads to hype about AI. In this case, for instance, by saying that AI will soon be powerful enough to pose civilization-wide risks. And I think this is an example of something that's quite pervasive today, and especially by public figures who talk about the harms of AI. So coming back to the map, in addition to prominent AI results being exaggerated, public figures also distract from the real issues of misinformation that is likely to arise when people over-rely on these tools, or perhaps the labor implications of tools, by pointing to sci-fi threats like civilizational collapse. And both of these together mean that there is rampant AI hype in many of the sources of information that are available to people. Finally, the way this information is conveyed to the public closes the feedback loop of hype. So here's a screenshot of what popular news headlines look like right after Microsoft launched their Bing AI chat, which relied on GPT-4 under the hood. The New York Times said, "Bing's AI chat, I want to be alive." There were other outlets, for instance, saying things like, "Are AI chatbots turning sentient?" And we think that when the public is faced with headline after headline claiming that AI could perhaps be sentient, that has a really negative effect on how the public could treat AI systems, perhaps as being sentient. The really sad thing about all of this is that we have known for at least 6 decades now that when humans interact with AI-based chatbots, they are likely to anthropomorphize them, to treat them as if they were human-like. So for example, this is an image of Eliza, a chatbot that was developed by Joseph Weizenbaum in 1966. Eliza is an example of a really simple chatbot. All it is doing is sort of parroting back your responses in the form of a question. And even technically, it is extremely rudimentary. It just has a list of rules on the basis of which it asks the next question or sends the next message. So for example, Eliza could start with something like, is something troubling you? And the person might respond, men are all alike. Eliza would just respond with a fairly generic question in this case. What is the connection, do you suppose? And so on and so forth. The really interesting thing about Eliza is not how it was designed, but rather the effect it had on people who interacted with it. Many of the people who talked to this chatbot would, after the conversation, refuse to believe that they just talked to an AI chatbot, that they hadn't really talked to another human. This was termed the Eliza effect as an example of the implications of treating AI systems as if they are human-like. And so given that we have this vast amount of understanding and like many experiments showing that humans tend to treat AI systems as human-like, I think it is particularly sad in some sense that these news outlets claimed that Bing's AI chat, in this case, was turning sentient. So rather than informing their readers about how to watch out for symptoms like the Eliza effect, they were actually feeding in to the hype. And this, I think, completes the feedback loop of AI hype. So when journalists uncritically report on AI and exploit our cognitive biases like anthropomorphism, this essentially completes the feedback loop of AI hype, especially in the public sphere. Okay, and I'll quickly hand it back to Arvind for a brief overview of what else is in the book.
Sure. Maybe I will just take 1 minute if, just to share some final thoughts, and then really look forward to what Thomas has to say. So many people started paying attention to AI after ChatGPT came out, but in fact, it goes back 80 years. So this is a screenshot from the 1950s, and the history of neural networks actually goes back to the 1940s. Let's keep going on this slide, Sayash. So we have a whole chapter discussing why it is that we've talked a little bit about what goes wrong when we try to use AI to predict the future, and I briefly mentioned research by our Princeton colleague Matt Salganik. We summarized that research. We have a lot of other research, and there's a whole chapter in the book that doesn't even talk about AI, but it's more about a sociological understanding of why the future is hard to predict. Then there is existential risk that Sayash already mentioned. We talk about the role of institutions. I'll save this for the Q&A. What we mean by broken AI is appealing to broken institutions. We talk about regulations a little bit. We talk about AI and children, the role that AI is going to play in the life of a child born today, for instance, we think is going to be much more significant than it plays in our lives today. But anyway, we'll save all that for later. For now, we just want to mention that the book is available for purchase. And with that, we look forward to hearing what you have to say. Thank you.
Thanks, Mr. Narayanan and Mr. Kapoor, to give us this presentation and to give us a very fundamental definition of what is AI, what essentially AI is, and what AI can do, and what those kind of the problems that AI cannot solve. Especially, I really admire this part, like Mr. Ariana said, okay, AI cannot predict the future, and he just gave us some kind of the examples and the reasons why AI cannot predict the future, which is really, I think this is a really crucial part for us to understand what AI can do and what AI cannot do, right? So but my question, I will read some kind of the question. So my question may pretty focus on the part of the AI hype, because we really every day, I'm a journalist entrepreneur, and we pretty focus on AI, and we do a bunch of this kind of the AI coverages. We talk with the AI figures and AI companies, and to get a deeply experienced on those kind of the AI hardwares, AI devices, or the AI language models, or this kind of things. And we do a lot of this kind of things, and sometimes we sort of like, and we are in a way to blindfolded run towards those kind of the AI papers, or the AI companies, or the AI prototypes, or AI products. But we strongly feel that there are a lot of this kind of the AI hypes. Yeah, I can just raise you an example like a week ago, my company hosted our own AI event in Beijing, right over here in Beijing. Before the event, I set up a rule. To prohibit our speakers to use the buzzwords like AGI or scaling law or this kind of things. The rule I set up, this rule is established because each speaker or panelist can put his or her own stamp on the envelope of AGI or generative AI or scaling law. Each one can give their own understanding on that, which causes more misconceptions or confusing, I think. Yeah. So during the event, I think I tried my best to remind each one, okay, we won't talk about AGI today. Don't mention that word. Don't mention scaling law. What you are doing is not based on the scaling law. Okay, we cannot say that. I tried my best to do that, but still, in some of the sessions, we unconsciously to talk about AGI or this kind of things. Yeah, I think this reflects then how we get used, or how the whole industry, I mean the AI industry get used to enjoying this kind of the buzzwords. Even most of the time, we probably unaware of this kind of a situation. Yeah, so let's talk deeper about the AI hype. Yeah, I think the last chart is talking about who made this kind of the AI hype, or this kind of the exaggerated AI claims. Who made that kind of things? I think both of you conclude this kind of the people into three groups. One is that the AI companies who are selling their products, their AI products or their AI solutions. And the second group is the AI researchers, like you guys, the AI researchers, who spread out a lot of these papers or this kind of things. And third group is the people like us, the journalists or the reporters or editors who are covering AI. So my first question may start from the group like us. So no, I just noticed different kind of the medias have different attitudes or standing points on AI companies, I think. Yeah, for the for AI, for professional or very vertical tech or AI media or AI outlets, I think we always just portray over optimistic light to AI products or AI companies, while the mass media always remind people the harm or this kind of the risk of AI. I think this is very interesting. But each of this kind of the media get this kind of the people's attraction, I think. In my team, I'm always struggling on this kind of things. I sometimes guard my team to use those kind of the very moderate words or very balanced tones to tell AI stories, to describe AI product, or to comment how AI company makes senses to the society, to its users. But I sometimes struggle to get traffics competing with those kind of the other medias who have very strong opinion who provides very fruitful emotional value instead of an insight provider. So I think, I'm not sure, how can you guys tell me, okay, whether is this an unsolvable dilemma, or how the mass media, or no matter the mass media, or even the tech media can do this kind of things better to let more people, not only for the industry, but the masses, all the people, to have a more clearer and neutral understanding on what AI is, how it works, and what's the background technology behind that.
Thank you. Yeah, that's a very hard problem from the perspective of journalists to know how to cover AI in a more responsible way while also competing with other journalists who might not have the same standards. I think in general, this is a challenge all throughout journalism, not just in AI. And so I think the solutions are going to have to be broader and maybe not specifically about AI. I can share a couple of thoughts, but you're the expert, so I'm curious to hear what has worked for you and what has worked less well for you as well. So one thought is that, as you pointed out, this is very tied to the business model. So if the business model is based on clicks, of course, it's going to be hard to have more in-depth coverage. One thing I've noticed in the United States media ecosystem is that the journalistic organizations that want to provide in-depth factual coverage tend to move towards a different business model. It's subscription based, where readers want to come back month after month because they know that this outlet is going to give them good information. Some of them are becoming nonprofits where they are funded by donations in order to do in-depth reporting. And that's not necessarily just for AI. That has been true historically, where a lot of the most in-depth reporting comes from more nonprofit journalistic organizations than the ones who are competing for clicks. Another is just to have self-regulation, I think, among journalists. And we have been to a few journalism conferences, for instance, again here in the US, where journalists are discussing how we can all do better and hold each other accountable, right? Where they work together instead of necessarily always competing with each other. And one last third suggestion is perhaps a different kind of content when you're covering something that's in the news, when you want to cover a product that a company put out, for instance. It's hard to do that without hype because you have to make it seem like this is something remarkable, something that is worth the reader or viewer or listener paying attention to. And when you're covering something dangerous about AI, again, you have to hype it up because you have to make it seem like this is very special. But there is another kind of content, right? Another kind of content might be an interview with someone who is working in AI, for instance. And it seems like people really love these in-depth interviews. Podcasts, so, for instance, in the US, we have podcasts like Joe Rogan, which have become enormously successful, have become media empires on their own and really competing with traditional media outlets. So that is surprising to me. And it's a sign that people really want this kind of in-depth content that comes from a journalist talking to an expert. So that could be another kind of content where you can have more depth.
Oh, that'd be great. Just from my own experience, I recently, just during the past probably a year, the most, the major channels for me to get deeper understand on the most cutting edge AI technology, or this kind of the models, or this kind of the researchers, or the business ideas are coming from those kind of the podcasts hosted by VC firms like Andreessen Horowitz or Y Combinator or No Priori, or this kind of the VC guys who are hosting this kind of the podcast instead of TechCrunch, The Verge, or Business Insider, or this kind of the mass media. I think this is because this kind of the insiders, no matter they are VC guys or entrepreneurs, they can get better understanding on what they're doing. But one following question, highly relevant to that, is that, do you think that the reporters or the journalists who are covering AI need to read AI research papers frequently, probably in a weekly basis, or read AI research papers frequently to know more about that. Because most of the journalists, include myself, I read papers frequently, but for myself, I think I'm still with not an AI background or the computer science background. I'm not with that background. It's sometimes just give me some kind of the challenges to read some details. But thanks for AI tools like ChatGPT or Cloud, right? Do you think it's really needed for non-AI background journalists to read AI papers?
Yeah, I think that's a great question. So, I mean, in some sense, it depends on the sort of journalism that you're doing. So, for example, for science journalists who are reporting specifically on the contents of a paper and comparing it to the previous state of the art, I think that is a very important skill to have. But for other types of journalists, for example, people looking at the impact of AI on society, I'm not sure if that's the most high value way. So I'll give you an example. One of the journalists whose work I really like in the US is Timothy B. Lee. And a lot of his work is related to self-driving cars. So he reports on the state of progress on self-driving cars and so on. But a lot of the insights that he has are not by reading papers on the state of the technology, but rather by looking at the statistics from companies like Waymo and Cruise, by looking at the statistics released by government organizations, by comparing the regulatory stances on self-driving cars across the states in the US. And that does not necessarily require deep academic expertise, but it does require being able to find the right sources and being able to read government documents or being able to track down companies' reports when they are releasing them. And I think we're at the point, or at least slowly beginning to get to the point, where AI companies are also starting to figure out what they communicate to the public. And many of these sort of nuggets of information are hidden within this large reports that companies release. So I was part of this initiative called the Foundation Model Transparency Index. Mm-hmm. And companies were required to or asked to report 100 different things about how they train their AI models. And I think there were some very interesting insights in a lot of what the companies reported, which were not related to academic insights really, but which were more about where do they get the training data from, or how much do they pay their workers when they're annotating data, and so on. And so if people are looking at sort of the impact of AI on society, then I think this type of secondary information can be quite useful and important.
Oh, that'd be great. Get more access to the data and facts to get better understanding about AI. Okay, let's talk further about the researchers like you guys. Researchers sometimes may still spread some kind of the AI hype to the public. Yeah. So, and now in some kind of the could you please I will raise you some kind of the AI researcher figures like Jeffrey Hinton, and you just mentioned, right? Or Yellow Kun, a guy I like him a lot, I think. And probably Feifei Li, I think. And I think, would you please to give some kind of the comments on their role to be a, or would you please to give the comments on these figures and their roles to the public to tell about what are they acting in the right way to tell the people the right thing about AI? How do you think about it? Would you like to give some kind of the comments about this kind of the peers in the AI researcher field?
Thank you. I'm happy to share some comments on that. I think there are a couple of reasons why AI researchers are often hyping AI too much, and I'll share some thoughts on how they can do better. One is, if you look at the reason why researchers are getting into AI. I mean, let me tell you my own story. 25 years ago, when I decided that my undergrad major would be in computer science, it's because one day I wanted to build AGI. I wanted to help build it. I really liked your rule, by the way, and your conference of not talking about AGI. I think we need more of that at more events. But nonetheless, the fact remains that many AI researchers are thinking about this. It's this kind of North Star, and it's, obviously many researchers believe that it can completely transform the world if you had AI that could do any job that any person could do. And so a lot of people are coming into the AI field because they have a kind of religious belief, right? That this world-changing thing is achievable. And so you're starting from a baseline of people who believe in something radical. I'm not saying that, I'm not talking about whether that belief is true or false, but you can imagine if someone is really committed to this mission, if you will, then they're going to believe some things that might sound really radical or crazy. So I think that's part of the reason. And a second, more mundane reason is that everybody needs to get funding. I mean, Jan LeCun and Jeff Hinton, for them, they're pretty well set. They don't need to hype AI to get funding. But for a lot of other researchers, unfortunately, if you put out a press release touting how amazing your new invention is, you get more attention, potentially more funding, and so forth. And even in our research, we are often thinking carefully about our paper titles. Are we exaggerating this too much? So I think that's a struggle for every single AI researcher. And a third
Okay,
thing, I think
so
something new. Yeah, sorry, go ahead.
just go
Can I
ahead.
share one last thought on that? In terms of how people can do better. So one thing that's changed, AI used to be a really niche topic, and then it was okay for AI researchers, to say some crazy things because the people who were paying attention were mostly other AI researchers. But the extent to which the public and the media are now paying attention to what AI researchers are saying is, of course, on a completely different scale. Now, AI researchers have become public figures, and many researchers have not yet understood this fact that for public researchers, there's a higher ethical standard for any kind of public figure that we should hold them to, and what they say matters, and they can't just say whatever is on their mind all the time. And I think there needs to be a culture change.
Oh, that'd be great. So is that to say that researchers, I mean, researchers being entrepreneur will be harmful for the original AI research because then this will give them the added motivation to make the AI hype. Is that right? I mean, AI researchers, be entrepreneurs.
Sayash, do you want to take?
Yeah, sure. I mean, I don't think there's an issue with researchers becoming entrepreneurs per se. I do think like a big challenge with the AI tools that we have today is that we don't really have enough real world users that are being sort of productionized. And so maybe that is something we need more of. But I think the specific challenge with AI hype and entrepreneurs is I think researchers are seen as this trusted public figure who talks sort of dispassionately about scientific research and communicates that with the public. And when they turn into entrepreneurs, then they become people who have something to sell. And I think this sort of transition, even though there is no clean line, this sort of transition needs to be appreciated by journalists writing articles about people who now have like a business incentive to sell things and not just treat them as neutral, independent parties. And I think that is what needs to be emphasized a lot more. So when an entrepreneur or like someone who's trying to sort of set a company off the ground says something about that company, that should be seen as a statement by someone who has a financial interest in that company, rather than a statement by a third-party expert who has a dispassionate view to some extent on the workings of that company. And I think that is what we are sort of trying to wrap our head around right now, simply because we have seen this huge boom in AI in the last few years. This wasn't a problem maybe 20 years ago when AI was useful for a few things other than, I don't know, like this type of AI was useful for maybe handwriting recognition or whatever. But all of a sudden, it has become a consumer technology. And so we're seeing a huge boom of researchers turning into entrepreneurs. And I think we need to treat their claims with a little bit more skepticism, especially when it's about their products or their industry.
Okay, that'd be great. Yeah, sure. Still talk a little bit more about the AI companies and who have the strongest motivation to to a hype, just in a way, you may rather say in this kind of the AI, the advertisements, yeah, displayed on YouTube about AI companies or AI products or even their websites. I mean, the AI companies' websites are all AI hype. I think in a way we can say that. So how I mean, just how the public can how the public can get a better understanding from those kind of the advertisement materials or this kind of the different advertisement videos, and we always see this kind of the Grammarly or the ChatGPT, even now Cloud. I mean the Cloud powered by Anthropic, and they just display their advertisement in San Francisco airport on the YouTube and everywhere, and how people just get the right understanding from those kind of the advertisement materials and to have a more balanced and objective understanding about AI by reading or by hearing or by watching this kind of things, yeah. Or anyone or anybody or any organization can play a more moderate role to change this kind of a situation. I think that advertisement about AI now is everywhere. It's everywhere, especially in Silicon Valley and Bay Area.
I'll say that there's one really big good thing about generative AI compared to, let's say, predictive AI. If a company comes out and claims, "Oh, our AI can predict who is going to commit a crime," and that's their advertisement, there's nothing you can do to check that claim for yourself.
Yeah.
Generative AI is very different. If ChatGPT or Claude claims that AI can do, I don't know, whatever it is, legal work, and if you're a lawyer or have some legal expertise, that's a claim you can check for yourself. And that's a much more efficient way of doing it than, trying to figure out if their advertisement is hyped or not, or reading journalistic articles, or even, listening to this talk or reading our book. There's something much more high value you can do with your time, which is to play with generative AI products yourself, right? Just within a few hours of using it, you're going to get a pretty good understanding of its potential as well as its limitations for the specific use cases that you care about. And I'm sure many of you are already doing that. I very much encourage you to continue doing that. And keep in mind that AI is not just ChatGPT or Claude. It doesn't have to be specifically a chatbot that you go and type into. AI is integrated into a number of other software products that we use on an everyday basis. So when you're interacting with AI, be mindful of that. Use that as a way to develop your intuition on what it's doing well, what it's not doing well. When you're on social media, remember that so much of content out there is AI generated. So use that as a way to update your understanding of the kind of realistic images that are possible to create with social media. So yeah, basically, my advice is through the course of our everyday interaction, both with AI products and other kinds of software products, we should be constantly reflecting on that and updating our intuition for what AI can and cannot do, generative AI specifically, at any given point in time.